Okay, we're back. I just wanted to introduce for you this idea about the wild filter. Here in the wild filter, I've got the prefix, the suffix, and the midfix. And what I do in here is I let you introduce just a suffix, which is the most common way that you build a wild filter. And also I let you put in a prefix and a suffix, and also the prefix, suffix, and midfix, and even an array. And then the logic gets rather more complicated. If the suffix is not null, then I use the suffix, and if there's a suffix array, I'll use the entire array of suffixes. These are candidates which can be used for the ends. So it could end with any one of a series of different strings. You can see how complicated that gets. So because the complexity is arbitrary with respect to the accept method, that's one of the reasons we call it polymorphism. Any implementation can be used that will satisfy the contract, and the contract is the contract that comes from the file name filter. And that requires you have an accept method. Let's move on. Oh, really? That doesn't sound good. So chapter 15 is on streams. We should be up to that by now, I think. What is a stream? Yes, Brian. How is stream defined in the book? A stream is an unformatted sequence of bytes. And that's it. A stream is critical for being able to do things like I/O on a network. Stream is critical for being able to do things like I/O at all. You can't do I/O without a stream in Java. There are two kinds of streams in Java. There are input streams and there are output streams. Input streams implement the input stream interface. Output streams implement, yes, the output stream interface. The implementation for the input stream interface returns bytes, and the implementation for the output stream interface allows you to write bytes. And you have no idea how these things are implemented, so it's another example of polymorphism. Right? It's built into the API of Java, because you can write a device driver that reads bytes and writes bytes to an arbitrary device. It could be a USB device with a scanner, or it could be a label printer, or it could be something that reads and writes from a network card. You don't know. And so at some level, if you wanted to build something that, let's say, transmits data from one computer to another, let's say using a laser in free space, you could write a device driver that just takes bytes and outputs those bytes directly to the laser. So this unformatted sequence of bytes, it sounds like it would have relatively limited utility. What could I possibly use it for? And the answer is everything. Really everything. But it's unformatted. And what does it mean to have unformatted bytes? Well, what it means is if you transmit 4 bytes, you don't know what was meant. Right? 4 bytes could be an int. 4 bytes could be half a long. 4 bytes could be an int with 4 bytes in any order. First, the least significant byte or the most significant byte. You don't know. Or maybe it's 2 chars. Or maybe it's just 4 bytes. Or maybe it's a bunch of floats. You know, a float, that's like 32 bits. That's 4 bytes. Or maybe it's half a double. Or maybe it's half a double backwards. You don't know. It's unformatted. So because you don't know, when you transmit that data, either your receiver knows what you meant, or you have to somehow provide more information so that the receiver can figure it out. That's really critical. Unformatted bytes, you better know what it is you're reading. And if you are reading in a structure, a data structure, and you expect it to be payroll, but instead of payroll it's a bunch of shoe sizes, then that data structure is going to be meaningless. It'll be gibberish because you won't know how to decode it. So an unformatted sequence of bytes it's almost as though you're in the data link layer, right? You're just passing data from one point to another. Binary data processing is the most common kind of data processing, and it's also the most difficult because you're dealing with this raw data. It's typical for you to find implementations of an input stream and an output stream. For example, the file input stream is an implementation of an input stream. File output stream is a kind of output stream. It provides a way for you to write bytes. They end up going to a file. That's fine. But as it happens, this is a very important kind of input stream and output stream. For byte streams, there's a bunch of them. I'll say there's an ecosystem of streams. And they all implement either the input stream or the output stream interface. Byte array input stream is kind of interesting because what you can do to the byte array input stream is you can make it from an array of byte. So if you have an array of byte, you can disguise it as an input stream and start reading the bytes one byte at a time off of the array. There are object input streams. Now the object input streams are no longer unformatted sequence of bytes. Instead what you're doing is you're reading in instances of classes. So an object input stream, if you have an instance of payroll and you go to a file and you read it as an object input stream, that's great because it's going to come back as an instance of payroll. And when you take an instance of payroll and you write it out as an object output stream, you're going to be saving your payroll. And it will come back as a formatted data structure. So that enables you to obtain what's known in the biz as persistence. That allows your object, your instance, to persist from one run of the program to the next. So if you've got your accounting system being stored in a file, at least when you restore it, you'll be able to get it back to where you were. It's saved. So that's very convenient. But it only happens when you use the higher level streams, like the object output stream and the object input stream. There are other things you can do too. You can have a char array. And you can write out with a reader and a writer arrays of strings, or an arrays of characters, which are strings. In order to be able to use an object input stream and an object output stream, your class has to be special. And the special nature of the class is such that it implements what's known as the serializable interface. So objects will not persist unless they implement the serializable interface. Moreover, you cannot take instances of classes and pass them across a network unless they implement serializable interface, which means you can't do parallel computing in an object-oriented fashion unless your classes implement a serializable interface, because there's no other way to marshal the parameters across the network for distributed computing. That is, you have to be able to take an instance of an object and convert it into an array of bytes. Once you do that, once you have an array of bytes, you can move the array of bytes across any stream. and that stream can be a file output stream, it can be a socket, it can be any kind of a pipe, anything that can take an array of bytes. So taking an instance of an object and converting it into an array of bytes, and then taking the array of bytes and converting it back into an instance of an object is known as the serialization of the object and the deserialization of the object. It's so important. So being able to manipulate streams is an essential part of data processing. And this kind of data processing is the kind of data processing that you would do in any one of a number of circumstances, whether you're writing device drivers or doing software engineering or doing something with giant databases. You need to be able to do this kind of data processing. If you go out onto the network and you find a URL, you can get a URL to give you an input stream, and you can read the data off of that URL directly. And you can interpret it as an array of char, if you like, but if it happens to represent, if that array of char happens to represent HTML, you're going to want to parse the HTML in order to be able to extract the data and do data mining. A lot of times your file input stream can be used for binary data, but can be used for text as well. Normally, if it's used for text, we make an instance of a reader. And if you use a buffered reader, usually it's made from a file input stream or a file reader. So when you think about what it is you need to do in order to write your own input stream variant, you have to implement a way in which to read bytes. And usually what happens is you pass in a byte array and it populates the byte array. That way you can reuse the byte array. That's your buffer. If the input stream is unlimited, like streaming radio, then you can't use the available method because it doesn't know how many bytes are available. Could be an infinite number of bytes, right? Think about it a different way. A microphone on your computer is streaming data that's unlimited in size. So when the microphone is being used for your data processing and you have a streaming input off the microphone, available is meaningless. It could be an infinite number of bytes available. Probably there are certain things that I tell you to do that I don't do myself, even though I know I should. Closing your files when you're done is one of those things you really should do. Always close your files when you're done, whether you're reading from them, or writing to them. And there are a couple of reasons for this. Usually when you're writing to a file, if there's a buffer, closing the file will flush the buffer and make it so that the file does not become corrupt. So you won't have a bad file when you're done. Always close your files when you're done. Of course, if you forget to do it, like I often do, and your files become corrupt, hey, don't come crying to me, because I told you, always close your files when you're done. There's another way you can go if your data isn't appearing on the output and you want it to. Let's say you have a console and you're starting to write data out and it doesn't appear in the console, but you don't want to close the file, you can flush the buffer. Flush the buffer will cause all of the characters to be emitted out to the console so that the user will see what's going on. There are ways to put a little bit of structure onto bytes. There are data input streams and data output streams. There's a piped input stream and a piped output stream. You've probably seen piping being used before. You can use it in on a Mac. You can even use it in DOS. Piping will take data from one output and put it into another tool's input. For example, dir lists a whole bunch of stuff. Dir piped into more takes the output of dir and puts it into the more program so that you can go one screen full at a time. You can do a very similar thing on a Mac. You can say ls, that doesn't work on this DOS system, and you can pipe it into more, and it'll do the same thing as dir piped into more. But you'll see here, ls is not a proper command for DOS. So you'd have to, you could do it on a Mac, but not under Windows. You could do it under Unix. This is a classic example of no general agreement about what the command should be for doing something as simple as listing files. Does everybody know how to bring up the DOS prompt? Yes? That's cake, right? How about the terminal window on the Mac? Do you know how to do that? Yeah, okay. So you can do the pipes within Java. To be honest, I've never really gotten into using pipes with Java, but I think that would be fun. So here's an example of reading in text data without using a file reader. In this case, I'm opening up some test file.txt, and then I make my own buffer. Normally I use a buffered file reader because that's convenient. But here I'm making my own buffer of 50 bytes, and then what I do is I read in 50 bytes at a time and write them out directly. And I only write out the number of bytes actually read. And I keep doing that until there's no bytes left. And so that allows me to do things like this, which enables me to copy a file from a file input stream to a file output stream. Does it have to be a file input stream? Could it have just been an input stream? Sure. And if you did that, then you could pass in an arbitrary input stream and an arbitrary output stream. And here's my file copy program in action. And that's another idiom right in there, where it says the number read is not equal to -1. When it's equal to -1, you have an end of file. And it's doing this one character at a time. So it reads a character, and then it writes the character out. And when it's done, it's closing its files. You always close your files. Input streams are funny. Sometimes you want to sniff at the input stream to see what's there, decide what kind of data it is, and then pass the input stream to the next program. But because you've corrupted the input stream by sniffing it, you've moved the pointer slightly. So with a push-back input stream, you can reset the pointer to the beginning after you've sniffed a little bit to see what kind of data is present. This happens a lot in image processing, where users are inconsistent with the suffix that they use for the file. Like they might say, well, this could be a JPG file, or maybe it's a JPEG file. Or maybe I'll just name the file .img for image. So then your program is sitting there wondering, gee, I wonder what kind of file this is. Well, by sniffing the input stream, checking out the first few bytes, deciding what this must be, and then pushing the data back, you get to reset the pointer on the input stream, and that's what a pushback input stream is about. This is probably too much detail. There's a book with a bunch of examples in it, and I leave it to you to read it. We're in chapter 15, is it? Streams? I wonder if we should do an example with an object input stream and an object output stream. Would that be fun? Object input stream, object output stream? Example? You guys are overwhelmed with enthusiasm? There might already be an example here. So let's just check real quick. Yeah, here's a good example. So here's the customer, and now we can see that the class customer is a little bit different from other classes that we might have seen before. And the difference is it implements serializable. Serializable enables me to take the customer and persist the customer into a file or transmit the customer across the network. I can take this customer and convert the customer into an array of bytes, and then I can print out the byte array. So here we are, test read. We call get bytes. We get the serialized instance. Comes in as an array of bytes. I'll take the array of bytes and I'll use it as an argument to a byte array input stream. So a byte array input stream converts the array of bytes into an input stream, and now I can take that input stream and pass it into an object input stream. Now I could take the object input stream and call read object, which should give me an instance of a customer. And I'll just set it to the primordial object class. And if that object, O, is an instance of a customer, then I'll cast it and I'll print the customer. So here's an example of taking an instance of a customer that's been persisted to the file, converting it into an array of bytes, and then converting that array of bytes back into the customer. That's slick, right? Let's see if we can do this again. Oh, and there's more. There's more. There's a keyword, probably the last keyword you'll encounter in Java that's a new keyword. Transient. Does anybody know what the term transient means in Java? Transient means do not persist. Transient means when you go to save, the value will be set equal to null. That's very important because sometimes you have references to larger systems and you don't want the whole system to be saved. You only want some subsection of the system to be saved. Sometimes you have references to things that make no sense to save, like an instance of a window or a frame that have been opened and is transient in terms of your runtime and won't be present for drawing later. So that shouldn't be saved either. So by declaring a variable to be transient, you prevent it from being persisted. So let's see if we can do a run on this and get an example going. Oh, he wants a serial file for input. I haven't saved anything yet. Here's student data. Let's call this test read. And what I'll do is I'll make a little main method and we'll test the write. Oops. There we go. What did I do wrong? There we go. So let's see what test write does. I've got this data structure inside of the student data class, which consists of things like the name of the student, J Schmo. J Schmo is a Joe Schmo or Jane Schmo, an equal opportunity Schmo. The grade is 100, and the student data can be printed. So I'll do a toString method for SD. Presumably the toString method has been implemented. Let's see if that's true. Yep, there it is. Here's the toString method. This gets invoked whenever you take an instance and you concatenate it with a string. So it'll print out the name and the grade. Let's see, what else? It says here, select a file for output, and then it says file output stream right in here. So F will now be the output file, File output stream is then used as an argument to the object output stream. So when I write objects, that'll flow to the file output stream, which will then flow to the file. I'll write the object, student data, out, and then I'll close the file. After we're done, what I'm going to do is I'm going to use DOS to try and edit that file so you can see what's actually been written. So let's write out an object. I think that sounds like a good time. So we'll put it somewheres. Where shall we put it? Got any favorite places for these things? You want to put it somewhere you can find it. How about we put it in J for P, data, I'll just call it junk.txt, even though I know it's not a text file. And he says it's done. So now let's go in to oops. Junk.txt is there. It's got 184 bytes to it. Let's run Notepad on it. That'll confuse Notepad, I'm sure. Junk.txt, what could that possibly say? And there it is. Binary data. Ain't that pretty? It looks like Chinese. So then, actually I think it is. I mean, doesn't that look like an ideograph there? So junk.txt got written. Let's see if we can read it back in. Disconnect. And what we'll do is we'll do a test read. Now, test read. Now what test read's going to do, does this have to throw an exception or something? Yep, there we go. Class not found exception. Test read expects an object to come back, and that object is going to be converted into a string. So the toString method, which is a part of the primordial java.lang.object class, will be invoked, and presumably the student information will be printed. So let's try that. We'll select a file for input. Junk.txt, and there it is. J. Schmo, grade 100. So we've successfully serialized using the object output stream and then decoded using the object input stream. Pretty cool, right? And if you use Notepad to read it like we did, you'll see it was just gobbledygook. It looked just like binary data, which is all it was. Nice, compacted binary data. But we got our object back. Now let's use transient. Okay, I'm going to use transient on the name. Now when I serialize by saving the object output stream, I'll do a test write again. We'll call it something else now. Let's call it junk2.txt. Now what we'll do is we'll try to read it back in. And what does that buy us? It says null, grade 100. So by setting the name to transient, we can ensure that the name will not be saved. And that's key. How about those files? Now you're doing object output streams, object input streams. You're doing file I/O. How fun. You have to go, right? Yeah. Catch you later. So here's an available mechanism being used, FIS available, and you know that's not going to work if your input stream is an unlimited stream. So you can't rely upon that, except perhaps in the case of a local file system. And I'm going to skip some of this stuff because it's too much data, because it goes to, now we're doing random access files, and that's one of those advanced topics I don't think we're going to need. And here comes serialization. And we know now why we need serialization. You can save things to a file, but also you can transmit objects across the network. How cool is that, right? So remote method invocation becomes possible using object serialization. If you have something that isn't Java and you want to invoke it remotely, you can use what's known as the Common Object Resource Broker Administration, or CORBA. That enables you to do invocations remotely. So let's say you're working in Hartford for the insurance company. They're programming in COBOL because that's what they've always programmed in. But they hire Java programmers. So how do they invoke the COBOL programs remotely from their Java machines? They use CORBA. If you're in Sikorsky and they have a whole bunch of Fortran programs that they wrote back in the 60s for doing structures, which they have, use CORBA in order to be able to invoke those programs remotely from your Java programs. So if you have Java programs that are remote and you want to invoke them, use RMI, but if you have other languages, you can use CORBA. So we already saw the example here, only with a more advanced object. This one is saving out the time. And deserialization is how I decode the object to read it back in. So now your stream, which is an unformatted sequence of bytes, has become formatted by virtue of the object input stream and the object output stream. Now you're no longer just writing bytes, you're writing instances of classes, and that's far more compelling, far more useful. But what happens if you go in to read a customer and it's not a customer, or you can't find the customer? You'll throw a class not found exception at runtime, CNFE, class not found exception. And so it's very important that you know what's been stored, because when you go to read it in and you cast it to customer and it doesn't cast to a customer, it's broken, and you've broken persistence. And therein lies the Achilles heel of everything I just told you. Everything I just said is wrong in terms of being able to work if what you're going to do is change the class. Because a class is a cookie cutter, and an instance of a class is the cookie. And if you change the shape of the cookie cutter, the cookies will not fit in the cookie cutter. So when you go to take the cookies and pass them back through the cookie cutter again, they won't work. So if you went to your class after you persisted it, and you added a variable, and you added a method, and you changed an interface, there's no way you can do the casting back. In that case, your persistence is broken, and nothing will read back in. So that's so important. So if you've got a big address book program like I have, with 5,000 something addresses, if you change the basic primal instance of an address by adding a new field, you'll break your database and you will lose all of your addresses. That's so critical. It's so key. So being able to be very disciplined about how you change your data structures is really rather important. And if you know your data structures need the flexibility of being changed, you don't persist your objects in this way. You use something else. Use XML. Use comma-separated values. Use a text file with a well-known format and a version number. But you don't persist your objects in this way, even though it's convenient, even though it's efficient, even though it's fast. Because it's not that flexible. And I guess this doesn't add anything to the discussion. There's an awful lot of exceptions that can occur when you start to do file I/O. File not found exceptions, class not found exceptions, corrupted stream I/O exceptions, all these interesting and wonderful exceptions. The question of how you handle it, I don't know. What I've done in this example, I just print the stack trace and it dies. You may find that a little less than elegant, especially in a production code example, but that's what I'll do for a class example. I'll just try and catch the exceptions. And we talked a little bit about transient, but now we can talk about compression. And there's a whole bunch of different interesting and wonderful compressors available to you in the I/O package. The zip compressor and the gzip compressor and the jar compressor all enable you to take relatively large file names. In the case of jar, I think it's almost an unlimited number of characters in a file name, and you can store them in a directory structure just like a file system, but it all goes to a single compressed file. And you can control the compression rate, you can control how much CPU time is used, and the way these things work is they use dictionary lookup tables. So they take sequences of bytes that are common and they develop code words for them. And then they transmit the code book as a part of the file, and you use that code book to do the decoding. I'm not going to do the AU files. Let's see. I'll skip the AU files because that's audio. And I don't have good applications yet for piped I/O, although I kind of wish I did. Let's see. That's about it for me, and that's about all the time we have. I'm looking at my watch and going, I better wrap this up. So let me come up with a different assignment than the homework that I had assigned prior to this, because I don't think you're ready for it, and it seems like the URL was not correct. I think you should be doing the reading. How's that? Let's do the reading out through chapter 18, which is swing. How many people here have done a little swing programming? Just one or two? Brody, not you? No? Brian, no? Kyle? No? What kind of swing programming did you do? Here you did games. What kind of games? Oh, wow. Yeah, I like games. Do people here like games? Somewhat? No, you don't like games. Oh, really? They made you do it, that's why. I used to program games for a living. Oh, really? Oh. I think I've got a game. I used C++. Here's a game. Is that what a fun game. Oh, very fun. Look, I'm winning. Uh-oh. Wait. Ah! Oh, I'm still winning. That's good. Hey, is this being recorded? Ah! I don't know what that is going to look like on Vimeo. Ah! Ah! Oh, the computer wins. Oh, no. I got to put in another quarter. Oh, wait. No, I don't. I'm a programmer. I can do what I want. Yeah, there's a game. So I think we're not ready to program our own game yet. But I think it would be fun to do that, especially if it was a network game. A massive... Uh-oh, you don't like that idea?
But we just failed really bad.
Oh, Well, we've had people do network games in our Java 3D course. Massively multiplayer online first-person shooter game. I called this one Kill the Student. Every student gets an avatar, and they're walking around in this maze, and we all have guns. And guess who wins? There are compelling arguments for doing games because people seem to like them, and there's a lot of programming involved. It's interesting stuff, and there's like networking and everything. But what I'll do instead is I'll just get really boring and I'll in a reading, because I don't think I should assign a game yet, because that's too hard. So chapter 18. Let's see if we can get up past that. And one of the things that I see in the swing chapter, which you might not have done, is an HTML viewer. And I think that's kind of important because what it does is it lets you open up HTML. If I had some HTML, I'd open it, and then render it on the screen. So you're kind of building a little browser, kind of a mini browser, mini-me. If I had some HTML here, I'd open it for you, but unfortunately I don't. I have to save it. So we'll make homework 2 something you do not hand in. It's a reading homework. You go out to chapter 18 in the book. Does everybody have a copy of the book now? Still coming in the mail? How will you do your reading? You know, I think you can buy them electronically from Amazon for like $9 or something. And they go straight into your Kindle. If you have a Kindle. Or it goes straight into your e-reader, if you have an e-reader. I don't know. Do people have e-readers? I don't have that. I have like an iPad. They have applications. Yeah, it's just an app. We got an app for that. Or you could just run it on your laptop. That's
they only give you a file. They send it to your Kindle app.
Oh, really?
Yeah.
Even if you buy from Amazon, you can't read it on your iPad?
You probably have to dig and find it.
Oh.
I don't know if you can actually. I don't think they actually give you the file.
Well, you know that the file is being stored on the computer somewheres, right?
Is it, or is it being stored in the?
No. You can read it when you're offline, right? Yeah.
I don't know. You need to open the Kindle app. That's all I know, and sign in.
Oh. Really?
Yeah.
Oh, how awful. All right. Well, I'm not. I really don't know about those things, so I'll leave it to you guys to decide how you want to get the book. Anyways, that's what I have for today. No homework to hand in, and we'll become swing savvy by this time next week. Thank you.